Hello everybody, welcome to Prince Master Champ Education with Fun. Today in this video we shall be understanding about quantum mechanics. What is quantum mechanics? What does it states? What formula does it use? And many more things. Well friends, before starting off this video, let me tell you that quantum mechanics cannot be explained in one single video. That is why we will only understand the basics of quantum mechanics and what it actually states. So let's start with our video. So first of all, we are going to start off that what is basically quantum mechanics. So we need to know the definition of quantum mechanics before understanding what it states. Here you go. What is quantum mechanics? Quantum mechanics is a fundamental theory in physics that provides a description of the physical property of nature at the scale of atoms and subatomic particles. Now, friends, atoms and subatomic particles, this is a very important thing to understand in order to understand quantum mechanics. Quantum mechanics is not a thing that we can just understand in a very short duration of time. It's a very difficult thing to understand. So for that you need to have the knowledge of subatomic particles and the structure of atoms. Now let us understand subatomic particles if you don't know about that. Okay, so the smallest material on the earth is an atom, the smallest material. So this I'm damn sure that this thing you have read in your school, or this is the thing that you might know, that this is the smallest matter, which is an atom. But let me tell you, my dear friends, that this is only correct to some extent. When we come to quantum mechanics, this thing is completely wrong. Why? Let me tell you. These atoms are also made up of more things, that are electrons, protons and neutrons. What are electrons? Electrons are the charges which have negative charge. Protons are the charges which have positive charge, and neutrons are the subatomic particles which have neither of the charges. That means they have both positive and negative in equal amount. Let's understand more. So let us take into consideration of this proton. We can again divide proton into more subatomic particles. Before that, let's see the structure of an atom. So here we can see that in the center there is a nucleus, and there are different orbits. You can see in this figure only, you can see here that only two orbits are there, and in other atoms or the other elements, let me say, there are more orbits as well, but in this only two orbits are there in which electrons are moving, and in the nucleus there are protons and neutrons. So as you can see, so these two things, protons and neutrons, are inside the nucleus and electrons are outside the nucleus. That means they would be orbiting, right? So now let's understand more deeply. So we have seen the subatomic particle proton. Inside proton you will find more subatomic particles, which are the down quark, one up quark and another up quark. Now what is the quarks, what are gluons, and what are these things that I am talking about? Let us understand that also. So this, what I have said you, that the subatomic particles are also divided into Higgs, bosons, gluons, photons, and these are again divided into quarks and fermions. I will show you. Here you see this, here we have the quarks, fermions and also the bosons. Let me tell you that bosons are different and quarks and gluons are different. Now quarks, and here it is written lepton. Now what is lepton? Fermions is the same thing as lepton. Now let's understand them. So in quarks we have the up quark, charm quark, top quark, anti-up quark, which is mostly not included actually, but still I have added this: anti-up quark, anti-charm quark and anti-top. So also we have the down strange, bottom, anti-down, anti-strange and anti-bottom quarks. These are the quarks that I have said you. There are even more. Let me tell you that here we have electrons, muons, tau, positron, anti-amune, then we have anti-tau, then we have electron neutrino, muon neutrino, tau neutrino, electron anti-neutrino and many more things. Well, that's hard to pronounce, I know, but these are the basics of quantum mechanics. Without knowing this, you cannot understand quantum mechanics at all. So we have, you see, there are also more, but I have included this much only. Now let's go to gluons. Now gluons are the things that attach these quarks together. We have photon. The photons are, you must have also learned that photon means light, so it is somehow relatable. Bosons, and there are Z boson, W plus boson and W minus boson, which also connected. We have also the Higgs boson, which is a complete different than all the other. So they all are categorized into quarks, leptons, we can say protons, gluons, bosons and Higgs. This is the structure of an proton, which you can see, which contains an up quark and another down quark. So in the between you can see, let me also mark it for you, this thing, this we can say the faint yellow color objects, these are known as the gluons, which we were talking about. Okay, now see why I have named quantum mechanics as one in all in one, because it is a foundation of all quantum physics, including quantum chemistry, quantum field theory, quantum technology, quantum information science and many more. And also it includes, let me tell you, classical physics. Classical physics, you will like, it's a quite very complicated thing, but it is also included in the quantum mechanics. Okay, so quantum chemistry, very difficult. Quantum field theory, the most beautiful theory. Quantum technology used in quantum computers. Quantum information science, also used in quantum computers. Beside them, you can see one formula which, you know, most of us cannot understand. What is this? This is the formula of quantum mechanics. Really means mind-blowing, right? So this is the formula of quantum mechanics. Now let me show you what exactly is written here. Yeah, now let us understand what does the quantum mechanics states. Quantum mechanics differs from classical physics, which I was just talking about, in that energy, momentum, angular momentum and other quantities of bound system are restricted to decreed values, which is also known as we can means it is pronounced differently in different ways, but let me just which is most accepted, quantization objects and have characteristics of both particles and wave, which is also known as wave particle duality, and there are limits to show how accurately the value of a physical quantity can be predicted prior to its measurements given to complete a set of initial conditions, the uncertainty principle. Now, first of all, whatever I have underlined, that are the main things which states quantum mechanics. Energy means, what is energy basically? Let me tell you. Energy is the capability of doing or completing a work. Momentum means it is the product of, we can say, the movement and velocity of an object. Angular momentum, the momentum of the object if the object is rotating. And bound system means the system which are to be done, right? So like here, what is a wave particle duality? This is very important, that is why I am telling you. Wave particle duality, it means if an object has a characteristic of both particle and wave. Like if I tell for example light is an object or a particle, I can say, which can be also expressed as a wave. We see the wavelengths of light. We also see the particles of light, which are known as, you know it very well, the photons. Let me show you what exactly is written here. Yeah. Okay, now so what is this principle, which is the uncertainty principle? Means uncertainty principle states that we cannot measure the particular momentum, particular energy, particular state of any matter directly. Okay, this is what the uncertainty principle states. Now let us understand that what exactly it deals with. So this what exactly it deals with? So the quantum mechanics deals with the behavior of matter and light on subatomic and atomic scale. It attempts to describe the amount for the properties of molecules and atom and the constituents, which are the electrons, protons, neutrons and other electric particles such as quarks and gluons, which we were talking about. And here's the formula shortened. Okay, so this is what basically the quantum mechanics says, and there is surely more to learn about quantum mechanics. See, quantum mechanics is a topic which cannot be, I have already said it to you, it is a vast topic. Means it cannot be just learned in a very short period of time. You see, this video is over 10 minutes and still we cannot cover most of the things that appear in quantum mechanics. There are surely more things to learn in physics if your subject is that, even after 12th grade. So that was all for today's video, and if you like these videos and want more such fun and amazing videos, be sure to like our channel, subscribe and also share this with your friends and families. As you know, this quantum mechanics was just a beginning, and you can see a paragraph which explains everything that quantum mechanics actually says. Not only this much but more is there, and see how complicated things are. Okay, so thank you for watching this video till the end, and I will be meeting you in my next video. Till then, bye bye everyone.